Okay, I'm recording this video in the classroom, so it's a little echoey. My apologies. And this is Unit 6.5, Parts of Similar Triangles. If you recall, when we talked about the definition of similar triangles, we talked about that angles have to be, the three angles within the two triangles have to be exactly congruent. They have to be exactly the same, but the sides are proportional, and that ratio, the proportionality, is established under, is called a scale factor, right? So whenever two triangles are similar, they have a scale factor. And so today we extend that definition a little bit, and here we say that if two triangles are similar, that's important, then the following corresponding parts are also proportional to the corresponding sides, meaning they are proportional according to the scale factor. So first of all, let's look at this. This is altitudes. Remember the definition of altitudes, which is the distance between one of the vertices to one of the sides. So that's my altitude. And because these two triangles are similar, ABC is similar to EFG, the altitude BD over FH should equal the scale factor, which is calculated by corresponding sides AB divided by FE. You can do the other two sides too, but any of the three sides would do, okay? Same thing with angle bisectors. So here I have these two angles are congruent, these two angles are congruent. So QS is an angle bisector and UW is an angle bisector, and their ratio should be the same as the ratio of one of the sides, which is QP over UT. Okay, same thing with medians. I have medians right here, and therefore the length of the median, HJ, over the length of the other median, LN, should equal the ratio of one pair of the corresponding sides. So let's look at some practices here. Triangle STU is similar to triangle DEC. Again, pay attention to the orders here. And now it looks like I have two, it looks like I have two medians here, right? Because these are congruent. Therefore, x over 15 should equal to 16 over 20. And if you solve for that, x comes out to be 12. Okay? Number 2, excuse me, is about altitude. It should be the same setup. Number 3 is the angle bisector. It's a similar setup as well. And I'm going to do number 4. Number 4 is an altitude. And remember, the altitude for an obtuse triangle lies outside. So this is the altitude for that obtuse triangle, and this is the other altitude. So if the two obtuse triangles are similar, then 12 over 15 should equal x over 42. And your answer should be x equal 33.6. Let me write out the answer for the others. And this one is x equals 28.5. Okay, so it's not challenging concept. As long as you have two similar triangles, their corresponding parts are proportional, and including these three parts, which is altitudes, angle bisectors, and medians, and they all are proportional. Let's look at number 5. I will move it up a little. Number 5, very similar. You've got the median here, so you know that they should be proportional to one of the sides, and except that algebra is a little bit more challenging. So you should have 12 times 2x minus 9 equals 20 times x minus 2. Now, what I should have done actually is this. I should have canceled this. So there's a 2 in there, so I should become 6, becomes 10. There's another 2 that becomes 3, that becomes 5. And rather than 12, I really should put in 3. Rather than 20, I should put in 5. So what I'm trying to demonstrate is whenever you can cancel, and then it makes the calculation significantly easier, because now you would have 6x minus 27 equals 5x minus 10, and that becomes x equals 17. Okay? So this leads us to a very important theorem called triangle angle bisector theorem right here. Whoops. Triangle angle bisector theorem. What that states is that if I have a triangle and I've got an angle bisector that separates the opposite sides into 2 segments, AD and DC. And these 2 segments are proportional to the length of the other 2 sides. So meaning AD over DC should equal AB over BC. So let's look at how this is used. Number 6, I've got, I was told that KM represents an angle bisector. So I've got the angle bisector here, and then I know this 2 must be proportional to the sides. So if I set it up, it's 4.8 over x should equal 12 over 18. And your final answer should be x equals 7.2. Number 8, again, KM represents an angle bisector, so this is my angle bisector, therefore there's my proportional. So 15 over this part would be 39 minus 15 should equal x over 36. Okay, and that should be 15 over 24 equals x over 36. If you simplify it, x comes out to be 22.5. And number 10, again, angle bisector is KM, so 27 over 45 minus 27 would give me this part. And the other side is 3x minus 9 over x plus 11, right? Because it's over there. We started from this side, so 3x minus 9 is on top, x plus 11 is at the bottom. And that gives you 27 over 18, so it should be 3 over 2 equals 3x minus 9 over x plus 11. So 3 times x plus 11 should equal 2 times 3x minus 9. And your final answer should be x equals 17. Okay, so that's it for this unit, for this entire unit actually. So as you can tell, Unit 6, it's very fast. It builds on triangle congruence, then extended into triangle similarities, and then we wrapped the concept of ratio and proportionality, ratios and proportionality into this unit. And then from there on, the extension is the some special parts such as the altitudes and angle bisectors and medians. Those are the 3 special parts of similar triangles, and they are proportional according to the scale factor. Finally, we wrapped it up in this video with triangle bisector theorem. And again, and that states that if you have a triangle bisector, the 2 segments bisected by the bisector on one of the sides is proportional to the other 2 sides of the triangle. So make sure that you complete the practices and the homework, and I will see you in class, guys. Bye.